Okay, this video is going to be the start of our imaginary numbers topic, but before we get stuck into imaginary numbers, we need to take a step back and talk about sets. Now, you'll often hear that maths is about numbers. That's sort of true, that's sort of not. What it's actually about at its heart is sets. So sets are even more fundamental than something like numbers, and it builds up to the rest of maths. So a set is just a collection of objects. Those objects can be numbers, but they can be other things that aren't numbers. So you'll often write your set with a description. So you'll write it in curly brackets and describe what's in your set. For example, this set that we've got here is all the numbers in between -2 and 4, including -2 and 4. So that would look like those red dots if you draw them on a number line. And x being in Z means x is a whole number. Z is the set of whole numbers. So I've also got here all the different sets that you'll come across with numbers. So Z is those whole numbers we talked about before. You've also got Q, which is rational numbers, and R, which is just any of your real numbers. So that's basically most of the numbers you can think of. That's going to be in that set R. Okay, we've also got symbols for sets when we combine sets together. So if we can combine them in a union, that means we're having the elements of both sets. So if you want to take all the multiples of 3 and the multiples of 5, you get a set with all the multiples of 3 and 5 in it. Whereas with an intersection, it's only keeping the things that are in both sets. You got the empty set there, which is a set with nothing in it. You got this little symbol n, which means cardinality. So that set that we're looking at above, n of a would be 7 because there's 7 things in that set there. You got a couple of symbols there. You've got element, which means something's in a set. You've got for all, used to say all the things in a set. And you've got there exists to say that there is something in a set. So let's do a couple of examples here. We want to list all the elements, all the odd numbers between 0 and 10. So that's sort of what this would look like here. So that would be sort of like 1, 3, 5, 7, and 9, and you would write out your set like that. That would be the answer to that question. You've got another question here, continents that start with A. So you'll think about all your continents and just pick the ones that start with A. You'd get a set that looks something like that: Australia, Antarctica, Asia, Africa. You would get numbers in the form 3k plus 1 for k equals 0, 1, 2, and 3. So if you think about k equals 0, you're going to get 3 times 0 plus 1, which is 1. If k equals 1, you're going to get 3 times 1 plus 1, which is 2, which is 4, sorry. And if k equals 2, you're going to get 3 times 2 plus 1, which is 7. There we go. And you can keep going on. K equals 3 would be 10, but at any rate, you're going to get that set there. Next set we're going to look at is Mr. Mill's favorite 3 video games. Remember, I said sets don't have to be numbers. There they are if you're interested. And then we're going to do some unions next. So if we want to calculate A union B for this set down the bottom here, you're going to take all the elements that are in A and B. So that's going to be 1, 2, 4, 5, 7, and 9. 5 is in both sets, but you just lifted it once there. So that's what A union B would look like. Then you're going to get A intersecting with B. So which elements are in both of those sets? Well, it turns out only 5 is in both those sets. So you'd write that down just like that. All right, next one we're going to do is we're going to do the set of prime numbers, odd numbers, and even numbers. So we can list out the first 10 elements in those sets and we get something that looks like this. Then we can start doing intersections. So if I'm looking for primes intersecting with even numbers, well, the only number that's prime and even there is 2. So I'm going to put 2, that's the set. Primes intersecting with odd numbers, well, pretty much everything from 3 upwards that's a prime number is also an odd number. So you're basically going to get this set, which is all that stuff there, which you do. Next one we're going to be looking at is primes union with the even numbers. So if we think about it, well, I'm going to get 2, 4, 6, 8, and then I'm going to add in any primes that I can have. So 5 is a prime, 7 is a prime, but I'm not going to have 9. I am going to have 11 and 10 and etc. All right, so that's what that set would look like. And then primes union with the odd numbers is going to look kind of similar. You'll chuck in all your odd numbers. So you're going to get 3, 5, 7, 9, and then you'll add in anything else if it's prime. So you're going to get 2, but that's the only prime number that's even. So that's sort of the set you're going to get, 2, 3, 5, 7, 9, and then it continues on like that. And that'll be it.